Welcome to our class Thermodynamics 1. What is thermodynamics? Thermodynamics came the root word thermo and dynamics. Thermo means heat, and dynamics is motion. Thermodynamics is that branch of the physical sciences that treats of various phenomena of energy and the related properties of matter, especially of the laws of transformation of heat into other form of energy and vice versa. Definition of terms: mass is the absolute quantity of matter in it. Weight is the force of gravity or Fg on the body. Newton's law states that the acceleration of a particular body is directly proportional to the resultant force acting on it and inversely proportional to its mass. Thus we have this formulas, and K is a proportionality constant. The proportionality constant can be substituted by this 6 value. It depends upon the given situation of the problem and the unit used. Relation between kilogram force and Newton. That 1 kilogram force is equal to 9.8066 Newton. And for relation between pound mass and slug. 1 slug is equal to 32.174 pound mass. Acceleration is a unit of force is 1 that produces unit acceleration in a body of unit mass. Exercise number 1. What is the weight of a 66 kilograms mass man at standard condition? In our solution, it is much better to write the given. This is very helpful when solving complex problems in order to analyze the problem easily. So, we have the mass of 66 kilograms mass and acceleration, which is equal to the standard gravitational acceleration of the Earth, 9.8066 meter per second squared. To solve the problem, we will use the formula that force gravity is equal to the quotient of the product of mass and acceleration and proportionality constant. Substitute the value of mass, acceleration, and proportionality constant. The value of proportionality constant can be get in our SPLM. Cancel the units that can be cancelled, then we have the value of force gravity, which is equal to 66 kilograms force. Exercise number 2. The weight of an object is 50 pounds. What is its mass at standard condition? Writing the given. From the formula of force gravity, we can solve the mass. That mass is equal to the quotient of the product of force gravity and proportionality constant and acceleration. Substitute the given value and solve for mass, thus we have 50 pound mass. Exercise number 3. Two masses, one is 10 kilograms and the other unknown, are placed on a scale in a region where G equals 9.67 meter per second squared. The combined weight of these two masses is 174.06 Newton. Find the unknown mass in kilograms and pound. Writing the given data. Solving first the total mass, thus we have 18 kilograms mass. Total mass is equal also to the sum of mass 1 and mass 2. Thus, we can solve mass 2. So mass 2 is equal to the difference of the total mass and mass 1, which is equal to 8 kilograms mass. Converting it to pounds, so we have 17.64 pound mass. Exercise number 4. A car whose mass is 2 metric tons is accelerated uniformly from standstill to 100 kph in 5 sec. Find the mass in pounds, the acceleration, driving force in newtons, and distance traveled. Writing the data given. For the mass, we can solve this directly by converting from metric tons to pound mass. So we have 4410 pound mass. We have other given data. To solve driving force, we need to solve first the acceleration using the formula that acceleration is equal to quotient of the difference of final and initial velocity and time. Substituting the known value and converting it to meter per second squared, thus we have 5.56 of acceleration. By using force-gravity formula, we can solve the driving force, thus we have 11,120 Newton. Density, specific volume and weight. Density of any substance is its mass per unit volume. Specific volume is the volume of unit mass, or the reciprocal of the density. Specific volume of any substance is the force of gravity on unit volume. Exercise number 5. What is the specific weight of water at standard condition? The standard density of water is 1000 kilograms per meter cube. To solve specific weight, we will use the formula that specific weight is equal to the quotient of the product of density and gravitational acceleration and proportionality constant. Substitute the values, so we have 1000 kilogram force per meter cube of specific weight. Exercise number 6. Two liquids of different densities, density 1 equals 1500 kilogram mass per meter cube, density 2 equals 500 kilogram mass per meter cube, are poured together into a 100-liter tank, filling it. If the resulting density of the mixture is 800 kilogram mass per meter cube, find the respective quantities of liquids used. Also find the weight of the mixture. Local G equals 9.675 meter per second squared. Writing all the given. From the formula density is equal to the quotient of mass and volume, we can get mass is equal to the product of density and volume. Using this formula, we can solve mass 3 is equal to 80 kg mass. From the statement of the problem, we can get this relation, that mass 3 is equal to the sum of mass 1 and 2. Substitute the masses with density and volume, we can make an equation, 1500 volume 1 plus 500 volume 2 is equal to 80, we will denote this as equation 1. For the volumes, we can get also this relation from the problem, that volume 3 is equal to the sum of volume 1 and 2, and we will denote this as equation 2. Using equation 1 and 2, we can solve volume 1 and 2, thus, volume 1 is equal to 0.03 meter cube, and volume 2 is equal to 0.07 meter cube. Using the formula, that mass is equal to the product of density and volume, we can solve mass 1 and 2. So mass 1 is equal to 45 kg and mass 2 of 35 kg. To solve force gravity, we will use this formula, substitute the value, so we have 78.926 kg force, or 774 Newton. Pressure. Pressure is the force applied perpendicular to the surface of an object per unit area over which that force is distributed. Standard reference atmospheric pressure is 700 mm mercury, 29.92 inch mercury at 32 degree Fahrenheit, 14.696 pound per inch squared, 1 atmospheric, 1.03 kilograms per centimeters squared, or 101.325 kilopascal. The device used to measure pressure. First is by using manometer, an instrument used to measure pressure as of liquids, gases and vapors. In using manometer there are two conditions, absolute pressure is greater than atmospheric pressure, and absolute pressure is less than atmospheric pressure. Second device used to measure pressure is by using pressure gauge. In this device you read directly the pressure of a fluid. Atmospheric pressure. Atmospheric pressure, also called barometric pressure, is the pressure within the atmosphere of Earth. The standard atmosphere, symbol, ATM, is a unit of pressure. The ATM unit is roughly equivalent to the mean sea level atmospheric pressure on Earth, that is, the Earth's atmospheric pressure at sea level is approximately 1 ATM. The instrument used to measure a barometric pressure is barometer. Specific gravity. It is the ratio of the specific weight of the substance to that of water. Exercise number 7. A pressure gauge reading 50 psig in a region where the barometer is 14.25 psia, find the absolute pressure in psi and Pascal. Writing the given. Using the formula that absolute pressure is equal to the sum atmospheric and gauge pressure. Substitute the given values, so we have 64.25 pound per inch squared, or psia. Exercise number 8. A 30 meters vertical column of liquid, density 1878 kilograms per meter cube, is located where G equals 9.65 meter per second squared. Find the pressure at the base of the column. Writing the given values. Using the formula, that pressure is equal to the product of specific weight and the height of the liquid. Substituting the specific weight by this formula. Thus the formula for the pressure will become like this. Substitute the given data, so you will have 543,681 Newton per meter squared, or Pascal, of pressure at the bottom of the column. Exercise number 9. The vessel contains gas, the manometer contains liquid whose density is 300 pound per feet cube with Hg equals 50 inch. Find the gas pressure in psi and Pascal, local G equals 32.11 feet per second squared, and barometric pressure equals 14.55 psia. Writing the given data. To solve the pressure of the gas, we used this formula. Substitute the given value. So, we have 8.66 pound force per inch squared. To find the absolute pressure, we will use the formula, that absolute pressure is equal to the sum of atmospheric and pressure gauge. So, substituting the given data, thus, we have 23.21 pound force per inch squared, or 160,026 Pascal. Temperature. It is a measure of the internal energy of a body, or is a measure of hotness or coldness of a substance. Absolute temperature. It is the temperature measured from absolute zero. Absolute zero temperature. It is the temperature at which all molecular motion ceases. These are the symbols of the different unit of temperature and the formulas. Exercise number 10. Derive the relation between degree Fahrenheit to degree Celsius. We can derive this by using interpolation. Interpolation is the determination or estimation of the value of f of x, or a function of x, from certain known values of the function. To know the steps of using interpolation, just follow the video. Simplifying the equation and putting the degree Celsius or degree Fahrenheit in the right side. You can derive the formulas. Conservation of mass. Law of conservation of mass states that mass is indestructible. The quantity of fluid passing through a given section is given by the formula. Applying the law of conservation of mass, thus, we can get this relation. Exercise number 11. Two gaseous streams enter a combining tube and leave as a single mixture. These data apply at the entrance section. For one gas, area 1 equals 75 inch squared, velocity 1 equals 500 feet per second, specific volume 1 equals 10 feet cubed per pound. For other gas, area 2 equals 50 inch squared, mass flow rate equals 16.67 pound per second, density 2 equals 0.12 pound per feet cube, at exit, velocity 3 equals 350 feet per second, specific volume 3 equals 7 feet cubed per pound. Find letter A, speed at section 2, and B, the flow and area at the exit section. To solve this problem, it's much better to make an illustration of the problem and the given data in order to analyze it well. For letter A, to solve the velocity, we used the formula that velocity is equal to the quotient of mass flow rate and the product of area and velocity. Substituting the values, so we have 400 feet per second of velocity at point 2. For letter B, finding the mass at point 3, we can solve this by adding the mass of 1 and 2, but we need to solve first the mass at point 1. Solving mass at point 1, we will use this formula. Substituting the values, then we have mass of 1 of 26.04 pound per second. Adding mass 1 and 2, so we can solve mass 3, that is 42.71 pound per second. To solve area 3, we will use this formula, substituting the values, so we have 0.8542 feet squared of area at point 3. Exercise number 12. A 10 feet diameter by 15 feet height vertical tank is receiving water with density of 62.1 pound per feet cube at the rate of 300 gallon per minute and is discharging through a 6 inches diameter with a constant speed of 5 feet per second. At a given instant, the tank is half full. Find the water level and the mass change in tank 15 minutes later. To solve this, first we will make an illustration to analyze well the problem. As we can see, we must identify the water in the tank whether increasing or decreasing. To find this, by subtracting the mass entering and leaving. Solving mass entering, using this formula, and substituting the given data. So, we have 2,490.64 pound per min. Solving mass leaving, using this formula, and substituting the given data. We have 3658 pound per min. Subtracting mass leaving to the mass entering, the result is negative, which means water level of the tank is decreasing after 15 mins. Using the mass of change and density we can get the volume of change, which is 282 feet cubed. So, the decrease in height of tank is 3.59 feet. Then, the water level of the tank after 15 mins is 3.91 feet.